Hello, space explorers, and welcome back to our cosmic journey. Today, we are resetting our sights on a planet that often gets called Earth's twin sister Venus. From a distance, it's a serene, pearly white jewel in the night sky, so beautiful it was named after the Roman goddess of love and beauty. But like a captivating mystery novel, the cover doesn't tell the whole story. What they didn't teach you in school is that beneath those swirling ivory clouds lies one of the most hostile environments in our entire solar system. Forget a gentle twin. Venus is more like Earth's chaotic, heavy metal-loving sibling. So, buckle up. We're about to peel back the layers and discover the real Venus, a world of fire, pressure, and mind-bending physics. Let's dive right in. The first thing you'd notice if you could magically stand on Venus's side from, instantly vaporizing is the heat. We're not talking about a hot summer day. The average surface temperature on Venus is a blistering 465 degrees Celsius, or 870 degrees Fahrenheit. That's hot enough to melt lead. It's even hotter than Mercury, which is much closer to the Sun. So, what's cranking up the thermostat to such insane levels? The answer is a runaway greenhouse effect. Venus's atmosphere is incredibly thick, about 92 times more massive than Earth's. And it's composed almost entirely 96.5% of carbon dioxide. This dense blanket of CO2 traps the sun's heat, turning the entire planet into a planetary pressure cooker. The atmospheric pressure on the surface is equivalent to being 900 meters, or about 3,000 feet, deep in Earth's oceans. You wouldn't just be roasted, you'd be crushed into a pancake. If the extreme heat and crushing pressure weren't enough to deter a visit, let's talk about the weather. Venus's weather forecast is consistently terrible. The upper atmosphere is home to thick clouds, but these aren't the fluffy, water vapor clouds we're used to. Oh no, the clouds on Venus are made of droplets of sulfuric acid. Yes, the same highly corrosive stuff you'd find in a car battery. This means it literally rains acid on Venus. While this acid rain evaporates before it hits the scorching hot surface, the entire atmosphere is laced with it. Any spacecraft or probe we send there has to be built like a tank to withstand not just the heat and pressure, but also this incredibly corrosive environment. It's one of the main reasons why missions to the Venusian surface have been so challenging and short-lived. The longest any lander has survived is just over 2 hours. Beyond the acid and the heat, Venus is a world of intense volcanic activity. The surface is dotted with thousands of volcanoes, more than any other planet in our solar system. While we haven't seen an active eruption with our own eyes, recent data from spacecraft like ESA's, Venus Express, and NASA's Magellan suggests that some of these volcanoes are still active today. We've detected fluctuations in sulfur dioxide levels in the atmosphere, and even spotted fresh-looking lava flows. This paints a picture of a geologically dynamic world, where the ground itself is constantly being reshaped by molten rock bursting forth from below. Imagine a landscape under a blood-orange sky, with volcanoes spewing lava and the air thick with the smell of sulfurites, a dramatic, almost biblical vision of a world on fire. It's not just a dead, hot rock. It's a living, breathing, and incredibly angry planet. Now, let's talk about something truly bizarre, a Venusian day and year. This is where your brain might start to hurt a little, so stay with me. On Earth, our day is about 24 hours long, and our year is about 365 days. Simple enough. On Venus, things get weird. First, Venus spins backward. While most planets, including Earth, rotate counterclockwise on their axis, Venus has what's called a retrograde rotation. It spins clockwise. No one is entirely sure why, but a leading theory is that a massive impact in its distant past literally knocked it upside down or reversed its spin. This backward spin is also incredibly slow. It takes Venus 243 Earth days to complete just one rotation. Here's the crazy part. It only takes Venus about 224 Earth days to orbit the Sun. Yes, you heard that right. A day on Venus is longer than its year. So what does this mean for someone living on Venus? Well, let's imagine you're standing on the equator. Because of the slow rotation, the Sun would rise in the west and set in the east. And you'd have to wait a very, very long time for it to happen. A solar day on Venus, the time from one sunrise to the next, is about 117 Earth days long. This means in one Venusian year, which is 224 Earth days, you would only experience about 2 sunrises and 2 sunsets. Imagine a day that lasts for months, followed by a night that lasts for months, and the speed of that rotation at the equator, a leisurely 6.5 kilometers per hour, or about 4 miles per hour. That's a brisk walking pace. You could literally walk fast enough to keep the sun permanently on the horizon, experiencing a perpetual sunset. How incredible is that? So, why do we care so much about this hostile, bizarre world? Because Venus holds crucial lessons for us here on Earth. It's a natural laboratory for understanding the greenhouse effect. By studying how Venus turned into a scorching hothouse, we can better understand our own planet's climate and the potential consequences of rising carbon dioxide levels. It's a cautionary tale written in the language of planetary science. Venus and Earth started out so similar, roughly the same size, mass, and composition. They are, in many ways, sister planets, but they went down drastically different evolutionary paths. Understanding what went wrong for Venus could be the key to ensuring we protect what went right for Earth. Future missions, like NASA's Veritas and Da Vinci Plus, aim to do just that, to map the surface in high detail and even send a probe plunging through the atmosphere to sample its composition. From its serene beauty in our night sky to its terrifying surface, Venus is a planet of extreme contrasts. It's a world where a day is longer than a year, where it rains acid, and where the ground is hot enough to melt metal. It's a powerful reminder that looks can be deceiving, and that the universe is filled with places far stranger and more extreme than we can imagine. The next time you see that brilliant evening star or morning star hanging in the sky, remember the chaos churning beneath its clouds. It's not a gentle goddess of love, but a raging furnace of a world that challenges our understanding of how planets work. Thank you so much for joining me on this deep dive into the secrets of Venus. What other mysteries of the solar system do you want to unravel? Let me know in the comments below. And if you enjoyed this cosmic journey, don't forget to hit that like button, subscribe to the channel, and ring the notification bell so you don't miss our next adventure into the great unknown. Until next time, keep looking up.